Hi guys, just talking to you today through some terms we use in algebra, basically to make things a bit easier in the long run. So here goes. Our title today is Simplifying Algebraic Expressions. So we might start off by thinking about some letters being added together. Now I might think about this as like me and my family are walking around the store and I pick up an apple. My wife picks up an apple, my son picks up an apple, and my daughter picks up an apple. Now all together, we've got 4 apples. Okay, now we wouldn't say we've got 4 times apples. I mean, it wouldn't necessarily be wrong, but I think if you were talking about this in your life, you wouldn't ever say, I've got 4 times apples. You say, I've got 4 apples. And I think you have to also realise that probably A doesn't mean apples. A probably means the cost of an apple. So say an apple costs 20p. You do much less maths if you're saying, okay, 4 times 20p is 80p. And you might also think, well, okay, say we went to a different shop and they were 25p. Instead of doing 25 add 25 add 25 add 25, you think I'll just do 4 lots of 25, which is £1. So you can make things easier by just putting things together and simplifying them up, which is why it's called simplifying algebraic expressions. So a much smaller thing to work with. So if I said we walked around the store and we picked up an apple, and then my wife picked up 2 apples, and my son picked up 3 apples, and my daughter picked up an apple, we could say altogether we had 1 apple, 2, 3, 4, 5, 6 apples, 7 apples. And again, if apples cost 20p each, it's easier to do just one calculation. 7 times 20 is £1.40. Now, we might not just stick to apples. We might have to get some bananas. So if I picked up 2 apples and my wife picked up 3 bananas and my son picked up 4 apples and my daughter picked up 2 bananas, you can see that if we're putting that together, we can just put the apples together. Now it's important here to include the sign with that as well. So 2 apples plus 4 apples is 6 apples, and then 3 bananas plus 2 bananas is 5 bananas. And again, A represents the cost of an apple, so say it's 20p for an apple, and B would represent the cost of a banana, so say it was 30p for a banana. Here I've got £1.20, there I've got £1.50, so £2.70 altogether. Is an easier way of working things rather than saying, right, I've got 2 times 20 there is 40, 3 times 30 there is 90, so 40 plus 90. You have much less maths to do in the long run, so making it simpler overall makes it much easier. Okay, so here we would have 6 lots of 20p plus 5 lots of 30p equals £2.70. Now, what would happen if, when we were walking around, somebody dropped something? So say we went to the basket and I picked up 5 apples, my wife picked up 3 bananas, and I gave them to my daughter to carry, but she dropped 2 apples. When I think about how I would just consider the signs, you could see that now in my basket I would have 5 apples take 2 apples, so that's 3 apples and just 3 bananas. and a more complicated one, let's think about the context disappearing. So we've got 5a plus 2b minus 3a plus 4b minus 5b plus 2c. I can only put together the things that have the same letter. So if I've got a's, I can say I've got this going on. So I've got 5a minus 3a gives me 2a, so they're sorted. When I look at the b's, I've got 2 b's there, plus another 4 b's, and then take 5 b's off. So I've got 6 b's, take 5 b's, that's 1 b. And if I said to you, what have you got in your hand? You would never say to me, I've got 1 banana. You'd say, I've got a banana. So we just put b down if there's only one of them. And what have we got left? We've just got the 1c left. Just 2 c's left. Okay? So that's basically covering adding. And when we're thinking about times in, we have to think about how we can shorten that down. Now, if I said to you, how would you write shorter 3 times 3? You might say, I'm going to write 3 squared. And it would be the same for a letter. So if I said I was going to do p times p, that would be p squared. And if I had to do q times q times q times q, you would say there are 4 q's times together, so that's q to the power of 4. So algebra, the letters work with the same rules as numbers, which of course they would do, because you wouldn't expect any different rules for multiplication, division, etc. Now it becomes slightly more complicated if you put extra letters in. So if I said we were going to do extra numbers as well as letters, if I said we were going to do 3p times 5p times 2p, well, if we think of the numbers, 3 times 5 is 15 times 2 is 30, and then the p times p times p is p cubed. So you just think about each bit separately. The other thing I need to talk to you about is division. Now, in terms of writing something as a division, I've said to you before about this symbol being just something that was invented for the calculator. So if we were to write p divided by q, it would be better off to write it as p over q. And if we had to do something like 25p squared divided by 5q cubed, you would say that's 25p squared over 5q cubed. But then if you just treat the number bit as a fraction, you can see that 25 divided by 5 is 5, almost like cancelling it down. 5 goes into there once, into there 5 times. So we'd have 5p squared over q cubed. And that really gets across some of the ideas that I'm looking for. So the idea that adding, you put the bits together and you would say repeated addition is a multiplication, which is what multiplication is. The idea that you can only add together bits that are the same, so you can only add a's together and you can only add b's together. You can't add an a and a b together, and that also works for if you had 5x plus 3x squared plus 7x. We would appreciate within doing something like that, that the 5x and the 7x could be added together because they have exactly the same letter to give you 12x, and then you'd have 3x squared, because for what we're dealing with here, x squared is different to an x. So coming back over here, we understand the idea about powers applies to letters, and if you have numbers and letters the same, you multiply the numbers and then take the letters to the powers. We've understood that this button on your calculator was created to represent this, and the line being division, and then the idea that if we've got any big numbers, we can cancel those out and simplify things even further. But the whole process, the purpose of the whole process is that to recognise that by making this calculation into a simplified form, we have less work to do when the numbers come into the problem. So remember, A was the cost of an apple, B was the cost of a banana. Once we understood that principle, so we're going 6 times the cost, 5 times the cost, it gives an overall cost. It gives us less work to do numerically in the end. And I think that's the important point to take from this. Right, okay, hopefully you've enjoyed that, and I look forward to seeing you soon. Thank you, goodbye.